In this particular lecture, we're looking at Chapter 10, Section 5. We already looked at it, but we're going to do a follow-up day. So this is day 2 of looking at Chapter 10, Section 5, Properties of Logarithms. And we are still pursuing and reinforcing and relearning and practicing state standard number 14, where we need to use 3 properties of logarithms that we learned in the previous lesson to simplify logarithmic numeric expressions and identify their approximate values. So let me just remind you the first particular law or property of logs that we had in the first time we looked at Chapter 10, Section 5. This says if you've got the log of a product. Now, product is the end result after multiplying 2 numbers. In this particular case, when you've got the log of a product, that's the same as taking the log of the first factor, taking the log of the second factor, and adding the results together. And as we said when we looked at this in 10.5 the first day, we said that logs turn multiplication into addition. And if you remember from elementary school, your first day of learning multiplication, your teacher may have told you that multiplication is just repeated addition. So hopefully it's easy to remember. Logs turn multiplication into addition. Our second property or law of logs that we investigated in 10.5 the first day is that if you got the log of a number to any base raised to a power, that's the same as that power times the log of the number. Or logs turn exponents into multiplication. Again, in elementary school, you may have learned that exponents is just repeated multiplication. So in this case, logs turn exponents into multiplication. And our third property or law of logs says if you have the log of a quotient is end result after dividing 2 numbers, or you may want to think of it as the log of a fraction to any base. You can take the log of the numerator, take the log of the denominator, and subtract that from the numerator. Or as we said, logs turn division into subtraction. Again, in elementary school, your teacher may have told you that division is just repeated subtraction. So again, logs turn division into subtraction. These 3 properties or law of logs are crucial for your success on the state standard test, since a big portion of it comes from Chapter 10, which is why we're spending a second day. Now, what kind of problems are you going to encounter? We're going to see something like this. We're not telling you what the base is in this particular case. It's a mystery base. I'm going to use the letter A. But whatever base that is, the log of 5 to that base is approximately equal to 0.67. So this symbol is approximately equal to. And to that same base, whatever it is, the log of 7 is approximately 0.81. Now, the state doesn't allow you to use calculators on the STAR testing, so what we need to know is they'll probably give it to 2 or 3 decimal places, and we'll have to do the math without a calculator. But the questions they're going to ask are something like this. Find the log of 25 to that same mystery base, given just these 2 hints. So you must know these 3 properties of logs, and let's give you a strategy for how to solve this particular type of problem. Now, in this example, I'm not telling you the base. But if for some reason you get one where they tell you the base, then you've got certain known values that we know from earlier in this chapter. So for instance, the log of 1 to any base is 0. Remember, logs are looking for exponents. 3 to what power is 1? Well, 3 to the 0 power is 1. Now, if that were 5, 17, 3/4, doesn't matter what our base is, anything to the 0 power is 1. Likewise, the log of 3 base 3 is 1, because log's looking for an exponent. 3 to what power is 3? Well, 3 to the first power is 3. So we know that. Likewise, the log of 9 base 3 is 2, because a logarithm is looking for an exponent. 3 to what power is 9? Well, 3 to the second power is 9. And it doesn't have to be base 3. This could be base 5. The answer is 0. Log of 5 base 5 is 1. Log of 25 base 5 is 2. So those are things that we'll need to know if they give us a problem where they tell us the base. What if they don't tell us the base? Well, we just saw that these three properties of logs involve multiplication, exponents, and division. So my second strategy step here is that we need to focus on using that in. So again, since the three properties of logs involve multiplication, division, and exponents, if they ask you to find something like the log of 175 to any base, we have to think of how we can recalculate 175 using the numbers 5 and 7 and involving the operations multiplication, division, or exponentiation, which is another way of saying that is raising it to a power. And so for this particular example, 175, I noticed in my mind that 25 will divide evenly into there. And we asked the question, how many quarters would give you $1.75? The answer to that is 7 quarters. So 175 could be written as 25 times 7. 25 could be written as 5 squared. So that is where you will need to do some calculating and try to figure out how you could represent this number in terms of the numbers they gave you. All right, so let's try a few of these and get used to practicing them, because we'll be seeing a few of these on the state test. We'll start with some simple ones. Log of 25 to that same mystery base, whatever it is. Well, can we represent 25 with 5 and 7 using multiplication, division, or exponents? And I know by now you've already seen that 25 is 5 squared. So the log of 25 is the same as the log of 5 squared, base A. That is our second law of logs, that logs turn exponents into multiplication. So in our next step, we're going to turn that into 2 times the log of 5, because the log of a number raised to a power is that power times the log of the number. Logs turn exponents into multiplication. And I'm using an equal sign so far because we are doing equality. But as soon as now I'm going to take the log of 5 and substitute and replace it with approximately 0.67, I'm going to switch to my approximately equal signs because we don't have exact values anymore. And if I find out what 2 times 0.67 is, that will be the log of 25 to this mystery base. Again, no calculators on the state test, so we've got to do paper and pencil or mental math. 2 times 7 is 14, so write down the 4, carry the 1. 6 times 2 is 12, add that 1 to it is 13. We need 2 decimal places in there, so it's 1.34. Again, 2 times 7 is the 14, carry that 1. 6 times 2 is 12, plus that 1 is 13. 2 decimal places. Log of 35, that'll be an easy one, because that's just 5 times 7. So that's the log of 5 times 7. And again, logs turn multiplication into addition. So we're going to look up the log of 5, look up the log of 7, and add the results together, not multiply them. Now, it's important you know these properties. Everybody knows that students make the mistake and they'll look up the log of 5, they'll look up the log of 7, and they'll multiply them together, and that's incorrect. So if I were making a multiple choice question out of this, I would look up the log of 5, look up the log of 7, multiply them together, and that would be your answer. And again, with no calculator, you're doing more work than you need to, because logs turn multiplication into addition. So we're going to look up the values of the approximate values of the log of 5, 0.67, log of 7, approximately 0.81, and add the results together, which will be a much easier computation without a calculator. That's going to give us 1.48. So again, 7 plus 1 is 8. 6 plus 8 is 14. We need 2 decimal places in there. The log of 35 to this mysterious base is 1.48. Log of 7/5, that's pretty straightforward. Log of a fraction, logs turn division into subtraction. So that's going to be the log of the numerator minus the log of the denominator. Substitute in those approximate values. Log of 7 is 0.81. Log of 5 is 0.67. And notice I switched to my approximately equal sign. Subtract, we get 0.14. 7 can't be subtracted from 1, but if we borrow a 10 from this 8, make that 7. 7 from 11 is 4. 6 from that 7 becomes a 1. Log of 7/5 is 0.14. All right, let's get back to that problem we talked about a minute ago, log of 175. We already showed you that that's going to be 5 squared times 7, 25 times 7. All right, so 5 squared is 25. You got 7 quarters. You got $1.75. Log of 75 is the same as the log of 5 squared times 7. We're going to need 2 of those properties of exponents to solve this particular one or simplify it. And the log of a product, that's what we're going to start with, is the log of the first factor plus the log of the second factor. Logs turn multiplication into addition. All right, then we've got log of 5 squared, so we need to deal with that exponent. Log of 5 to the second power is the same as 2 times the log of 5. Logs turn exponents into multiplication. Let's substitute in the approximate values for the log of 5 and the log of 7. So the log of 5 is approximately 0.67. Log of 7 is approximately 0.81. So I switch to my approximately equal sign. Let's double 0.67, which is 1.34. 7 times 2 is 14. Carry the 1. 6 times 2 is 12. Added to that 1 is 13. 2 decimal places in our answer. 1.34 plus 0.81, that's going to be 2.15. The 1 plus the 4 is 5. 8 plus 3 is 11. Carry that 1. 1 plus 1 is 2. 2.15 is what we get for the log of 175 in this mysterious base. All right, now this one, the log of 1, so far all we're given is 5 and 7. But we should know our little properties of logs from a previous episode that anything to the 0 power is 1. So a to what power is 1? A to the 0 power is 1. Now I'm not going to write this out, but another way you could do this is you could write 1 as 5 divided by 5. And the log of 5/5 is the log of 5 minus the log of 5. And that would be 0.67 minus 0.67, and subtracting anything from itself is 0. Yes, you could also say that's the log of 7/7. Log of 7 minus the log of 7 would be 0.81 minus 0.81, which again would be 0. All right, what about square roots? Well, the important thing to remember in this particular example is how to rewrite square roots without a square root sign. We learned earlier in chapter 10 that involves fraction or rational exponents. Remember, the radicand becomes the base. The root index, which is invisible, 2, because it's a square root, is the denominator of my exponent, and it's being raised to an invisible first power, which is the numerator. So square root of anything is the same as that number raised to the 1/2 power. Square root of 35 is 35 to the 1/2 power. Now, we've got the log of a number raised to a power. That becomes 1/2 times the log of 35, because logs turn exponents into multiplication. 35 can be written as 5 times 7, because we were given the log of 5 and the log of 7. Log of a product, log turns multiplication into addition, and I need these parentheses so I can sum those values and take half of it, or if you wish you could distribute it out, but it'll be easier if we just substitute in. So logs turn multiplication into addition. Let's look up the log of 5 as to what they told us. Log of 5 is 0.67. Log of 7 is 0.81. Let's simplify and add those together. 0.67 and 0.81 is 1.48. 1 plus 7 is 8. 8 plus 6 is 14. And we need 2 decimal places. Last step on this is to take half of it. It's the same thing as dividing it by 2. So we can see that 2 will divide into 14 7 times. Nothing left over. 2 will divide into 8 4 times. And so the log of the square root of 35 is approximately 0.74 to this particular mystery base. Now, just like the first day we looked at Chapter 10, Section 5, we had a problem like this. This one cannot be done. I know you're thinking to yourself, 12 is 5 plus 7. Well, it is 5 plus 7. But 5 plus 7 does not involve multiplication, division, or exponents. And remember that our three properties of logs involved multiplication, exponents, and division. So what we would need to do is to focus again on writing 12 in terms of 5 times 7, 5 divided by 7, 7 divided by 5, 5 to some power, 7 to some power, and then multiply those or divide those together. And since we don't know the base, it can't be done. It can't be simplified any further. All right, the log of 49/25. Again, logs turn division into subtraction. So that's the same as the log of the numerator minus the log of the denominator. 49, we were not given that. 25, we were not given that, but we were given 7 and 5. And hopefully you can see that 49 is 7 squared. 25 is 5 squared. So we're going to write this as the log of 7 squared minus the log of 5 squared. Again, logs turn exponents into multiplication. So the log of 7 squared is 2 times the log of 7 to that base. Log of 5 squared is 2 times the log of 5 to that base. Let's look up our approximate values. Log of 7 is approximately 0.81. Log of 5 is approximately 0.67. And then we'll need to do some multiplication. 2 times 0.81 is 1.62. 2 times 1 is 2. 8 times 2 is 16. We need 2 decimal places in my answer. 2 times 0.67 is 1.34. 2 times 7 is 4. 2 times 6, 14, sorry. 2 times 7 is 14. Write down the 4. Carry the 1. 2 times 6 is 12. Add it to the 1 we carried is 13. We need 2 decimal places. And we need to subtract. 1.62 minus 1.34 is 0.28. Again, 4 can't be subtracted from 2 unless I turn that into a 5 and borrow a 1 and make that 12. So 4 from 12 is 8. 3 from the 5 is 2, and 1 from 1 is 0. So the log of 49/25 is 0.28. So there will be several of these questions on the test. As we said, Chapter 10 has the most questions out of the 65 questions on the STAR testing of any of the chapters in our book. And to be successful in this, once again, you need to know these three properties of laws of logs. Logs turn multiplication into addition. Logs turn exponents into multiplication. Logs turn division into subtraction. And then again, let me remind you the strategy for this. If you're given the base, there are some of these values you can find without being told them. And if you're not given the base, whatever they're asking you to find the log of, you need to use the numbers given you, like the 5 and the 7, and see about multiplying them, dividing them, raising them to some power and multiplying, raising them to some power and dividing, or just raising to some power to try to figure out how to express that. So that's what we needed to be successful. And again, there won't be calculators, so you need to get familiar with being able to add, subtract, and possibly divide by 2, paper and pencil. All right, so that's our second look at Chapter 10, Section 5. We are going to have some homework problems that are just like this. No calculators allowed to prepare us for the tests.